This is a differential analyzer. There have been other Meccano models. This one is different, and it's a combination of designs from several builders. Its purpose is to solve differential equations. I know absolutely nothing about algebra. I'm hopeless with it, and so I'm afraid I won't be explaining any of the algebraic functions. But it has two integrators. That's these two parts here. And the turntables, the white circular platters, they spin and they represent the time. And the two wheels rest on the platters. They will supply the output, and the turntables move to the left and right, and therefore the speed at which the wheels spin varies. When it gets to the middle, they won't spin at all, obviously. If they move to the right, they will spin faster. And if they spin to the left, they'll spin faster but in the opposite direction, giving you positive or negative values. Here we have the torque amplifiers. These are ingenious machines that are quite old technology these days. The input to the torque amplifier is the wheel, and it's spinning on the disc, and so it doesn't have a lot of power behind it. If you try to drive the plotter or other things with it, it would just skid on the wheel. The torque amplifier, by means of the two rotating drums and the cords, which tighten or loosen depending on the direction, they will supply power to the output, which is at the back. I'll show that in a minute. And therefore we can use the output of the wheels to do useful things. The other part of the machine is the plotter, which is a simple XY plotter, and I don't think I need to describe that in any detail. We spin the machine round on my new turntable. Here we have the electrical control. There's only one motor that spins the discs, the platters, and the drums of the torque amplifiers. Each screw drive, ones on the plotter and the ones that move the discs back and forth, have micro switches at the end of the travel. There's a latching relay, and that acts as the main switch. But if any of the micro switches are triggered, they open the latching loop and the relay drops out and the machine stops. And here at the back we have all the linkage joining the parts of the machine together. These two long axles, they are the drives to the plotter, and the chains are the setup to enable the machine to draw a circle on the plotter, which is the way to test for accuracy, because it should draw a clean circle, and the beginning of the circle and the end of the circle should obviously meet. Now this doesn't quite happen, and that's to be expected with a Meccano machine. There's a lot of play in the axles moving. The holes are often worn and they're too big, and the gears are pretty sloppy, and all this adds up over time, and an error is to be expected. Next, we'll have a look at the machine working. There's already a pretty good circle on this piece of paper, and we'll use the same piece of paper to make a comparison. We'll lower the pen down onto the paper and we'll start. Obviously, I'm not going to show you the whole process as it takes about 15 minutes. Here's the start. We'll jump forward to the point where the circle is almost completed and we'll see what kind of an error we get. There is an error. This is to be expected. Meccano just doesn't make precision machinery, but at least it shows the basic principles of how these machines work. Another thing that I would like to show is that I have incorporated safety switches everywhere where there's a screw drive, because if the screw drive goes too far and it jams up, it's a really difficult thing to fix. It can often damage the screw threads. So if just to demonstrate, I'll start the machine and you'll see that this micro switch, if it were to be pressed in by the print head, that unlatches the relay and so the machine stops and the problem can be fixed. I have used non-Meccano 832 threaded rod for all the screw drives in the analyzer. It fits much better in the holes of Meccano. It's almost exactly the same diameter as an axle. The only problem is, of course, that you have to make your own die. This is how the torque amplifier works. The input comes in on the left and it's driven by the integrator wheel, which I've replaced with a simple wheel just to demonstrate. The shaft that goes through the amplifier, it looks as if it's all one shaft, but it isn't. It's actually two separate shafts that join in the coupling, but they're independent of each other. When we turn the input wheel, the movement is transmitted through the cords and the arms to the output, and as the drums are turning, the cord tightens up on whichever drum is going in the right direction, and that's what adds the power to the amplifier as the drum is gripped by the cord and therefore helps it to go round. The reason why there's two drums is the one for each direction. So I'll start it up. So if I turn the rubber wheel, you'll see that the arms are following my turning of the wheel exactly. The torque amplifier is also driving the screw drive for the X integrator through the chain. You can see it going back and forth, and it's also driving the plotter. And of course, it wouldn't be possible for the integrator wheel to do that without some kind of assistance, and that's why we have the torque amplifier. Well, this is my differential analyzer, a rather complicated way to draw a circle, but an interesting machine that served very valuable purpose during World War II. Thanks for watching.